Hello everyone and welcome in a new video. In this video we are going to understand about LRTF, longest remaining time first scheduling algorithm. In this video we understand that how we solve a question related to this particular scheduling algorithm, what are its how we basically solve a question with this scheduling algorithm. We see these things. Okay, so first of all we understand about scheduling criteria, how we solve this scheduling algorithm. So by its name it is clear that longest remaining time first means, so we are related to the longest something. Okay, so definitely in this scheduling algorithm we select that process who have a longest burst time. We are selecting that process, we schedule that process with the longest burst time. So what we are doing is we are scheduling that process who have longest burst time or with longest burst time. What happen if burst time is tie? So if there is a tie between the burst time, so means one process, let's say P1 having a burst time 10 and P2 is also having a burst time 10. So what happen when there is a tie between these two processes? So if tie, then we choose that process who come first. So means we are following the FCFS rule. First come first serve. Those processes who come first will get a CPU first. So in this case P1 and P2. So we assume that all come at 0 arrival time. So in this case P1 is a process which come first and then P2 is a process who come at second. So definitely P1 selected first and P2 selected second in a tie situation. Now what type of algorithm is this? What basically the type of algorithm, because we have two types of algorithm, preemptive, non-preemptive. This is a preemptive type of algorithm. What is the meaning of a preemptive type of algorithm? Preemptive means that if a process get a CPU and there is a one high prioritized process come in a ready queue, so what operating system do is operating system snatch the CPU from a running process and provide CPU to the highly prioritized process. Okay, so the process have to leave the CPU. In the case of high priority process. Okay, now let's see an example and we understand these things more detail. So we have a processes. So now we are selecting four processes, P1, P2, P3, P4, P2, P3, P4, and we have arrival time. Let's say the arrival time is 0. All the processes arrive at the same time, and the burst time. So the burst time for these particular processes are, for the P1 it's 9642. Now what you have to do is make a Gantt chart. First of all, make a Gantt chart. Okay, so what happen when there is when the scheduling algorithm is of preemptive type? What you have to do is you have to make one extra column for the calculations of the burst time. So 9. Okay, so 9. Okay, so why you have to do that? Because it's make clear that what is the latest value of a burst time. So 9642. Okay, now we have to make a Gantt chart. Okay, so let's create a Gantt chart. Now at 0 arrival time, because at initially what is the arrival time? 0. Okay, Gantt chart always start from a 0. This is a very important thing you need to understand. You cannot start from any particular number, you always started from 0. Now at 0 all the four processes are available. P1, P2, P3, P4, all the processes are basically available. Now what happen after that? When all the processes available, you have to choose that process who have a very high burst time. So among these four processes, P1 is a process who have a very high burst time, so definitely P1 will get a CPU till 3. Why till 3? Because when you execute it 3, the remaining time left is what, 6. So here you can see that there is a tie between these two processes, because P1 and P2, because both the process having a similar burst time. Now what happens if there is a similar burst time? We have to follow the FCFS rule, which says that those process come first will get a CPU first. So P1 and P2, between these two process, P1 is a process who come first. Okay, we see with this that which process come first with the help of arrival time, but in this case arrival time is what, 0. So we choose that process ID, we choose with the process ID. So P1 and P2, P1 is a process, 1 is basically less than 2, so P1 is a process who come first and P2 is a process who comes second. So this is how we choose a process. So if there is a tie, then what we have to do is P1 is a process which run again. So from 3 it run to 4. So when it run to 4, the latest burst time will become 5. The latest burst time will become 5. Okay, after that, among these 4 processes who have a highest burst time will get a CPU. So definitely P2 is a process who have a very high burst time, so P2 will get a CPU. P2 will get a CPU till only 1. Why? Because now when we execute it once, when the value becomes 5, what happen? Again there is a draw between the two processes, which is P1 and P2. There is again draw, so we have to select that process which come first. So among these two processes, P1 is a process who come first, so P1 will get a CPU. It run from 5 to 6. The completion of a P1 will 6. So it execute 1. So now the rest is what, 4. Among these 4 processes, P2 is a process who have a high burst time, so P2 will get a CPU. So from 6, the completion time of P2 becomes 7 and it becomes 4. Now the burst time is what, 4. Now we have 3 processes available to execute, P1, P2 and P3. We have 3 processes available to execute. Now in this case, what we have to do, we have to select that process who comes first. So among these 3 processes, P1 is a process which comes first, then P2, then P3. So P1, it execute only once from 7 to 8, so it becomes 3. After that P2 execute once, so it also becomes 3. P2 from 8 to 9, and P3 is also process who runs, so it also becomes 3. So it become the completion time of P3 is what, 10. Now again there is a draw. If there is a draw, again what you have to do is you have to execute in according to FCFS, which process come first, get a CPU first. So 2 P1 completion time 11, then P2 completion time 12, and then P3 completion time 13. So 2 2 2. Now there is a draw again, but now we have one more process available, which is P4. So we have to select that process which come first. So P1 come first, then P2, then P3 and then P4. So P1 from 13 to 14, P2 from 14 to 15, P3 from 15 to 16, and P4 from 16 to 17. Now the remaining burst time was 1. The remaining burst time was 1. So one burst time left. Select that process which come first, which is P1 17 to 18, P2 18 to 19, P3 which is 19 to 20, and P4 20 to 21. Now after that all the processes are now completed. So this is what a Gantt chart of this particular process look like. Okay, so this is how the Gantt chart is basically made. So I hope you understand that how we solve this particular type of scheduling algorithm, LRTF, longest remaining time first scheduling algorithm. Now what you have to do is you have to find out the average turnaround time and average waiting time. You can do it by yourself. That first of all, the completion time for P1 we have to see from our right side. So for P1 is there, completion time is what, 18. For the P2 completion time is 19, 20 for the P3, and P4 is 21. Turnaround time, completion time minus arrival time, so 18, 19, 20 and 21. Waiting time, turnaround time minus burst time, so 9, 13, so 20 minus 4 it's 16, 21 minus 2 19. So now you can easily find out the average turnaround time. So it becomes the sum of all the TAT divided by TAT, sum of TAT divided by the number of process. So in this question there is a 4 process, and similar thing you have to do with the waiting time, sum of all the waiting time, 9 13 16 19 divided by 4, you will get your answer. Okay, so this is how this scheduling algorithm is basically solved. Longest remaining time for scheduling algorithm solved in this way. Okay, so if you notice one thing here, that this Gantt chart is a very long Gantt chart. Okay, so we have to write so many processes to understand that what is the completion time of these processes. Okay, so to overcome this thing, what we can do is, there is a trick to solve this question. When there is a burst time is in an increasing order, or you can say that the arrival time is in an increasing order, or burst time value should be greater than the arrival time, then we do this cheat code. Okay, so what is the cheat code? Okay, so wait a minute. So what is a cheat code? So what is a cheat code? So cheat code is like that, let's say we have a processes P1, P2, P3, and arrival time, let's say 0. All the processes are available, and the burst time is like 3, 5, 4. So what happened in this case? You doesn't have to make all the burst times, all the initial burst time, because we know that all the processes burst time will draw at one particular time. Okay, so 5 is the highest, so 5 become 4. So when you solve 4, it become 3. So all the burst time, all the processes burst time will be same at one particular time. Okay, so when there is the same burst time, what we have to do? We have to select the process which comes first. So the sequence will be like P1, P2, P3. So sequence should always the same. So first of all P1, and then P2, and then P3. This thing happen. Whatever the initial processes is, whatever the combinations of these processes initially, we doesn't care, because we need the last one for the find out the completion time, because with the help of completion time we can find out so many things. So what you have to do is, because we know that all the process burst time should be same at a one particular time, and when there is a same burst time, so if there is a same burst time, what happen here? When there is a same burst time, we choose the process according to FCFS. So which process come first, get a CPU first. So this thing happen, and P1 is a process which come first, then P2, then P3. So the sequence of a process will be the same, P1, P2, P3. Now how we will write the completion time? So it's very simple. Completion time for the last process is what? The sum of all the burst time. So 5, 4, 9, 10, 11, 12. So 12 is a completion time for the 13. If you subtract 1, because we have to subtract 1, because you subtract 1, we are now other processes as well. So we have to choose from the other process, which process is the highest burst time. So there is always switching in 1. So here you can see that 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 11, 12, 13, 14. There is a switching between the one burst time. So definitely this thing happen. So 12 to 11 to 10. So we can easily find out the completion time for this process. And if you try to solve this question like this, that what we solve in this particular question, then it take a lot of time. You have to create a very big Gantt chart. So definitely there is a chance of showing an error as well as generating an error. So why we are doing these things? We know these cheat code, so we can easily apply these things. So P1, P2, P3, this is what a completion time, and you can easily find out that turnaround time, average TAT, and average waiting time. Now what happen if there is a arrival time as well? So we see that thing as well, that processes P1, P2, P3. Let's say we have 3 processes. Arrival time is look like 0, 1, 2, and the burst time is also look like 15, 6, 18, 15, 6, 18. Now what I told you, that if the burst time is greater than the arrival time, always remember this thing. If a burst time is greater than arrival time, then you have to do the same thing what we do in here. You are creating a Gantt chart. What is the initial value? Doesn't care. The sequence will be like P1, P2, P3. Why? Because P1 come at 0 arrival time, so P1, P2 come at 1 arrival time, then P2, and P3 come at 2 arrival time, then P3. We choose ID wise when there is a same arrival time. We choose with the seeing an arrival time when we have a different arrival time. So 0, 1, 2, these are the different values, so that's why we have to choose a process according to 80. So 0 means this process come first, 1 means this process come at second, 2 means this process come at third, and sum of all these things you will get the burst time, you will get the completion time. So if you sum this, you will get the completion time for the P3. So 15, 6, 18, it become 39, 38 is for the P2, and 37 is for the P1. So how simple is this? And if you try to solve this with the help with this approach, 1 2 3 1 1 1 1 1 1 continuously switching at one arrival time, one burst time, so definitely take 18 minimum 18 blocks you have to create, or more than 18 blocks basically, because 18 for the P3, 18 for 6 for the common, then 15 for the P1, 18 for the P3. So you have to create a lot of blocks. Rather than doing that thing, what we do, within a second we find out the completion time and completion time of these process, because all of we need these completion time to find out the different thing, average TAT, average waiting time, or whatever. So I hope clear to you that how we solve this. Now we see one more thing as well. If okay, so let's see process P1, P2, P3, arrival time was look like 320, and the burst time was look like 462. Now how you create a Gantt chart for this? So remember this thing, if this type of situation occurs, this is a special type of situation, you can find out that. Now what you do, you can't do now that you are writing P1, P2, P3, you can't do that thing, because initially the Gantt chart is started from a 0 and 0. We have one process P3, we have to execute it full. Why? Because the next wait is at 2, and the burst time of P3 is what, 2. So definitely P3 come, execute fully, and leave the CPU. So you cannot write 1 2 3. Okay, so you have to see these things as well, rather than blindly you are writing these things, writing the process in a sequence. What you have to do is you have to open your mind that which process comes first, you have to write that process, and you have to make a Gantt chart accordingly. P3, after that the same situation happen, because burst time is greater than the arrival time, so definitely all these things happen at that what we see in a cheat code. So now P1 and P2, which process come first, get a CPU first. So P2 have 2 arrival time, and P1 have a 3 arrival time. So P2 come first, so P2 will get a CPU, and then P1 will get a CPU. And if you are sum all these things, you will get 12, 6, 4, 10, 11, 12, and 1 minus means 11 is a burst time for the P2, 12 is a burst time for the P3, P1, and 2 is a burst time for the P3. So this type of situation is also occur, so you have to open your mind up and see these things accordingly. Okay, so this is what the longest remaining time first. Now we see the advantages of these things as well, that what is the advantage, so advantage is none. Okay, because we are selecting that process who have a very high burst time, so definitely there is no advantage, because only one process at a time can execute. One process is execute again and again and again and again and again, and there is continuous switching within a second with 1 unit of a time, so definitely we cannot use these things. Okay, and what is the disadvantage? So disadvantage is so many, like starvation occur. If a process have a smallest burst time in a queue, let's say that in a queue, okay, in a queue P1, P2, P3, P4, we have so many things. So P1 100, 200, 50, and 1. So P4 will come in an starvation. Why I say that thing? because all these processes have a highest burst time. So 200 is very high, 100 is high, 50 is high. So first of all P2 execute, then P1 execute, then P3 execute. So definitely it will take a lot of time. CPU will take a lot of time, and P4 is what, one unit of time. P2 need 1 unit of a time, but it will not get a CPU because this scheduling algorithm schedule that process which come first. Okay, so I hope it is clear to you that how we solve these questions, or what basically the disadvantage is. Okay, starvation, or what happened, and there is a disadvantage like convo effect also occur. Convo effect, CONVOY effect is also occur. Convo effect is also occur because one big process acquire a CPU, so for the smallest process have to wait for the indefinite amount of time. Convo effect is also occur, and there is no practical implementation. Not practical implementation. There is no use of this particular algorithm because we don't know about the burst time. So definitely we cannot implement this thing for the real life. Okay, there is no real life implementation of this particular scheduling algorithm. So this is what LRTF, longest remaining time first. Okay, thank you for watching this video. Like the video and subscribe my channel, and comment down the average T18 average waiting time for this particular question and for these questions as well.